Today's topics: measures of central tendency, mean, median, mode, and mid-range. The objectives for today: summarize data using measures of central tendency, such as the mean, median, mode, and mid-range. Just a reminder, back in Unit 1, a statistic is a characteristic or measure obtained by using the data values from a sample. A parameter is a characteristic or measure obtained by using all the data values for a specific population. Mean, median, mode, and mid-range. In statistics, the basic rounding rule is that when computations are done in the calculation, rounding should not be done until the final answer is calculated. Rounding rule for the mean, which is also for the other measures of central tendency, round to one more decimal place than occurs in the raw data. First step is the mean. The mean of a set of data is the average of that set of data. Population mean has this formula, that is the Greek letter mu is equal to the summation of all the data values divided by the size of the population. So that capital N, which is actually a Greek letter, is the size of the population. Sample means formula is very similar. The symbol for sample mean is X bar, and it's the summation of all the data values divided by lowercase n, which is the size of the sample. First example, find the mean of the hourly wages. An amusement park hires students for the summer. The students' hourly wages are given in the table, and there are 8 different data values there. To find the mean, you take the sum of the data and the number of values in our data set and divide them. It is money, so make sure you round to the nearest cent. So the mean is $7.35. Another example, find the mean for the data represented in the data plot and describe the distribution shape. So to get the mean, we need to average up all the data values. So we have 3 zeros, 2 ones, 1 2, 3 threes, a 4, a 5, and an 8. So we add up all those values and divide by 12. There are 12 data values there, and we get 2.5. Distribution shape, because we have 2 peaks, it's bimodal. Up next is median. The median of a set of data is the middle value when the values are arranged from smallest to largest. It is the midpoint point in the data set. Example, find the median of the hourly wages. It's the same data set we had in another example. An amusement park hires students for the summer. The students' hourly wages are given in the table. To get the median, we need to first put the data in order from least to greatest. There are 2 values that are in the middle, so we need to average those, add them up, and divide by 2, and our median is $7.62. Another example, find the median for the data represented in the data plot. So the values are already listed in order. There are 12 data values, which is even, so there isn't one exactly in the middle. If you count 6 in from both directions, our median is in the middle of 2 and 3. So we need to average those together. Add them up, divide by 2, our median's 2.5. Next up is mode. The mode is a value that occurs most frequently in the data set. It is sometimes said to be the most typical case. A data set can have more than one mode or no mode at all. When a data set has 2 modes, it's said to be bimodal. Example, find the mode of the hourly wages. It's the same data value from the amusement park hirees and their hourly wages. If we list our data values in order, it's easier to find values that duplicate themselves. $7.25 occurs most often, so the mode is $7.25. Example, find the mode for the data represented in the data plot. So mode is the value that's listed most frequently, and there are actually two. There are 3 zeros and 3 threes. So 0 and 3 are the modes. So this has two modes, which means it's a bimodal distribution. The mode is the only measure of central tendency that can be used in finding the most typical case when the data is nominal or categorical. Here's an example. At a political debate, a sample of audience members were asked to name the political party to which they belong. The responses are shown in the table. What is the mode of the responses? If we look at the frequencies, 56 is the highest frequency. It is the most frequent. So the mode is Republican. Next up is midrange. The midrange is a rough estimate of the middle. It's found by averaging the highest and lowest values. So to get the midrange, we add up the highest data value and the lowest data value and divide by 2. Here's an example. Find the midrange for the data represented in the data plot. And we are finding the midrange. The lowest data value is 0. The highest data value is 8. We need to average them, so we're going to add them up, divide by 2, and our midrange is 4. Practice problems. Here we have a data set in a dot plot, and we need to find the mean. So we need to remember what a data plot as a dot plot represents. There's one data value that's 77. There's 180. There are 3 86s, 189, 3 92s, a 95, and 4 98s. We need to add up all those values and divide by 16, which is how many data values we have, and the mean is 90.5. Median is the middle value. It's right in between those two because they are the same. Our median is 92. The mode is the most frequent value, and there are more 98s than any other data value in our data set. Midrange is the average of the high and low. Our lowest data value is 77, and the highest is 98. Add them up, divide by 2, our midrange is 87.5. And the distribution shape, this is real data, it isn't always picture perfect, but that would be J-shape. The most frequent is farthest to the right, and it decreases as we go to the left. Here's another practice problem. We have a data set. It's the number of hours spent reading by Mrs. Boone's students each week. It is a dot plot again. There are 2 students that read 1 hour, 3 students that read 2, 5 students that read 3 hours, 1 that read 4, 3 that read 5, and 2 that read 6 hours each week. The mean is the average of those, so we add up all those data values and divide by the total number of values. There's 16 dots in that chart, and all those values total 54, so the average, or mean, is 3.4. Median is the middle value. There's 16 values again, so there isn't one exactly in the middle. So we have to average those two. They happen to be the same value of 3, so our median's 3. Mode's the most frequent, and there's more 3s than any other value. Mid-range is the average of the high and low. The lowest data value is 1, the highest data value is 6. That gives us a mid-range of 3.5, and the distribution shape, once again, is not picture perfect, but it's best described as bell shape. Here's another practice problem. This time our data is given to us in stem and leaf plot form. Make sure we read our key. Here's our key. 7 line 5 is 75 megabytes. So our data values are 65, 70, 75, 75, 80, 84, 85, and 94. The mean, we would add up all those data values and divide by 8 because there's 8 data values there. We get 78.5. Mode is the most frequent, and there's only one data value that's listed twice, and that's 75. Median is the middle value. There's 8 values, so there isn't a data value that's right in the middle. We need to average the 75 and the 80. So we add them up, divide by 2, the median 77.5. Mid-range is the highest of the lowest, average of the highest and lowest data values. So we add 65 and 94 together, divide by 2, our mid-range is 79.5. The assignment for this lesson, there's a quizzes assignment. It's on measures of central tendency, mean, median, mode, and mid-range. It's going to be a 10-point minor grade. You have up to 3 attempts to improve your score. There's also an Edpuzzle video. It's finding mean, median, mode using a graphing calculator, and it's going to be very important that we learn how to use a graphing calculator when we get bigger data sets. That's going to be very important. And when we do grouped frequency distributions and finding measures of central tendency in those. This particular video does not do the grouped frequency distribution, but it's a good way to start with a normal data set. It's a 5-point minor grade for watching it.